Welcome back. In this video, we're going to be looking at the derivatives of both logs and exponentials. So let's start with logs here. For a function f of x equal to log base a of x, right? Then f prime of x is going to be x prime over the natural log of a times x. All right, so I have a few problems here that we can do. These ones are not particularly difficult. You just have to remember the general formula. So x prime is going to be this portion in here. We need to take the derivative of that. So we're going to say f prime of x is equal to x prime is just 5 over the natural log of the base. It's base 10, so ln of 10, times x, which is just 5x. So that's the derivative there. Let's move on. We have what seems to be something that is indicative of a chain rule. So f prime of x here, let's see, so x prime, we're going to bring the exponent down, we're just going to do chain rule on top, so 2 5x squared plus 5, keep that, and then we're going to take the derivative of that, bring down the exponent 10x, and then we're going to multiply that by the 2 here, so we get 20x. We could distribute that in, but to save time here, we're not. We'll keep it in its factored form. Then we need to take the natural log of the base, so ln of 3, right, times x. So x in this case is 5x squared plus 5 squared. And we can just do a simple simplification by canceling out one of our 5x squared over 5. So this simplifies to 20x over natural log of 3 times 5x squared plus 5 to the first. So you can kind of get the gist for how you take the derivative for a log. Hopefully your professor or whoever's teaching you your calculus would give you a formula sheet or a cheat sheet so you can put that notation down for that's how you take the derivative. All right, let's move on to exponentials. So it kind of is resemblant of logs in that we bring that weird natural log term in there. Everything else kind of makes intuitive sense except for that. We just kind of tack that on. So if f of x is equal to some value a to an x power, then the derivative of f of x is x prime times a of x, natural log of a. So what does that mean? So let's just take example 1, for example. So let's fill it out for f prime of x. We need to take x prime, which x in this case is the exponent, so we take the derivative. The 2 cancels out to a 0. Any constant's derivative is 0. 5x, that's just going to be 5. So our first part here is 5. Then we just rewrite our log. So this is times 7 5x plus 2. And then we just take the natural log of a. And a in this case is 7, so the natural log of that. So we'll just rewrite it here as 5 times the natural log of 7 times 7x plus 2 to make things look peachy keen jelly bean. Okay, so, and I'm sure there's other ways to simplify that. We won't go into that there. We're just looking at how we take the derivative. Now for number 2, I just threw in a little harder of an example. It's nothing crazy, but, you know, still a little bit harder, puts in trig function ideas. So for this, let's just go ahead and do it. F prime of x is equal to, so we're going to take the derivative of sine of 3x, which is 3 cosine of 3x. Remember, we take the derivative of the entire function with respect to the trig function's exponent. That just comes down to 0. Anything to the 0th power is 1. We take the derivative of the trig, which in this case the derivative of sine is cosine of 3x in this case. And then we take the derivative of the inside, and that just gives us 3. So we have 3 cosine of 3x. Okay, pretty simple here. So we have the derivative of a of x, and now we're going to rewrite the 9 sine of 3x. Okay? And then we just tack on that natural log portion. I'll actually shift this over just a tad so it doesn't get cut off. 9 sine of 3x times the natural log of 9. That's a really weird 9. Okay, so that's how we do exponentials and logarithmic functions for their derivatives. I hope you guys learned something today. If you did, please drop a like, comment, and subscribe. I would really appreciate it. Have a wonderful day.